In this video, we want to solve the exponential equation 4 to the x plus 1 is equal to 5 to the x. Let's use some methods that we've already looked at in previous videos. One of those methods was to rewrite this in logarithmic form. I can probably choose log base 4 or log base 5. Let's go ahead and use log base 4. So x plus 1 is the power that we raise 4 in order to get 5 to the x. Here, when I write it in logarithmic form, we notice that we're taking the logarithm of something to an unknown power. I would like to get that unknown out of that power, and a property of logarithms allows me to bring the x down in front and multiply by the logarithm. So we have x plus 1 is equal to x times log base 4 of 5. Log base 4 of 5 is just a number, so this is a linear equation in x. We solve it by getting our x terms to the same side. Subtracting x from both sides. I want to solve for x, so I'm going to factor an x out of this expression. And then log base 4 of 5 minus 1 is just a number. So let's divide both sides by that number. So here I've solved the equation for x. This expression is just a number. It is the exact representation of the solution to this equation. So in this method, we rewrote this in logarithmic form. We also know that we can take logarithms of both sides to any base we choose. If we had chosen to take log base 4 of both sides, we would have come exactly to this equation, and the rest of the solution would be the same. We could also take log base 5 of both sides, or use a more commonly chosen logarithm, like the natural log, or of course log base 10. So maybe we would try and solve this equation by taking the natural log of both sides. So we have the natural log of 4 to a power equal to the natural log of 5 to a power. We want to apply that power property of logarithms that allows us to bring these powers down in front and multiply by the logarithm. Again, I'm going to want to get my x terms to one side. On this left side, I'm going to distribute the natural log of 4 first. That frees up the x from this parenthesis, and then I can isolate the x terms on one side by subtracting x times the natural log of 4. Again, I want to combine these terms on the right side. Combining is a little difficult because of the natural log notation. So I combine by factoring out that x. And so x times the natural log of 5 minus the natural log of 4. This is just some number, so the last step is to divide by that number. So we get x equal to the natural log of 4 divided by the natural log of 5 minus the natural log of 4. This is an exact solution. It is the same solution as the first method, as long as you apply the change of base theorem and perform some algebraic manipulation. Let's look at one more method. I mentioned that it is challenging to come up with the same base like we've done in a previous video, but it is possible, and let's go ahead and look at that. If I want to write 4 as 5 to some power, then I can do the following. I can rewrite 4 as 5 to the log base 5 of 4.